So today we're gonna talk about angles. Last time we talked about segments and so forth, right? What are the two postulates we talked about yesterday? Last time. Yes, sir.
Ruler postulate.
Good. Ruler postulates and? Yes, sir. Segment addition postulate is correct. Okay, you knew that one too? Good. So, you know how we talked about those two postulates? We're going to be doing this very similar thing with angles today. Okay, that's what we did last time. Okay? So, what did ruler postulates tell us? It told us, what did it establish? It established the, yes, sir, the coordinate system on a number line, right? And not only that, it also told us how to find a distance between any 2 points. You basically take the absolute value of their difference. Is that right? We're going to be doing this similar thing today also. What did the segment addition postulate tell us? It told us that if you were to add two segments together, you get the whole thing, right? Yeah, of course, they all have to be collinear, right? Does that make sense? So that's what we're going to be doing with angles today. Okay, so keep that in mind. And of course, we got to sort of start with angles. So what's an angle? Well, angle is, of course, formed with two, anybody want to guess? Yes, sir. Two lines. Two rays. Good. Now, if you then you have to add something to that. Also, not only any two rays, but these two rays have to have common, yes, endpoints. That's correct. Very good. So remember, we always want to be on the same page. You gotta say it carefully. You can't just say two rays, because if you have two rays, they don't have to meet, right? And we don't want them to meet in any sort of different way other than where they have the common endpoints. So here's a picture. Angle is formed by two rays that have the same endpoint. And of course, these two rays are the size of the angles. Okay. Once you have an angle, we can talk about them being the size of the angle. Okay. By the way, there's a special name for that B. You know that letter, the point B, where the two endpoints, the common endpoints. Anybody know what that's? Yes, sir. Vertex, very good. It's called a vertex. So I'll give you the definition also. The common endpoints is the vertex of the angle, okay? So I'll give you time to write. Here we go. Okay, so there are many ways of, right, referring to this angle, right? How would you call this angle? Yes, sir. Angle B, sure, you could just do angle B. In this case, not every case though. Okay, in this case, you could call it angle B. We'll talk about why only this case. Yeah, what about? Acute angle. No, I want you to actually like name this angle. Yeah, how would you do it? Angle ABC, right? Are there any other ways? Yeah. Angle CBA. You could do the other way. Okay. Yes, sir. Somebody, no, right here. Yes, sir. Angle 1. You see that 1? You could actually call it angle 1. Oh, you didn't see the 1? Okay, it's there. Yes, sir.
Angle B.
Angle B. We said angle B. You're right. So I actually wrote this down. And notice, if you're gonna use 3 letters, notice that vertex is always in the middle. Isn't that right? That's important, okay? Because I cannot say what. Can I say this angle is called BAC? No, that'd be wrong, you see. Well, and why is it that I could actually use one letter for this angle, B, like this, in this case? What allows me to do that? Yes, sir?
Because there's no other angles that use the same vertex.
Exactly. If I had another ray like this, can I call that angle B? No, because then it could be one of the 3, right? It could be this angle on the top or bottom or the whole thing. We don't know, right? But since it's by itself, it's okay to call it angle B. But to be safe, if you use 3 letters, you know for sure which angle we're talking about. Okay, good. You all know that. Okay. All right, you all know this. What kind of angles are acute angles, guys? Angles that are, everybody say, between what? Between 0 and 90. Yeah, between 0 and 90. Okay, what if it's exactly 90? It's called a right angle. What if the angle measures between 90 to 180? Obtuse, you're right. That one, not too many of you said. Okay, that's the obtuse angle, you all remember? So you could classify these angles with angle measures, right? So if angle is measures between 90 to 180, call it an obtuse angle. What is a straight angle? Yeah?
An angle that measures 100.
Yeah, 180. Exactly right. Oh, you could remember we talked about opposite rays? Isn't that kind of similar? Opposite rays, straight angle, same thing. Okay. All right. Okay, are we good? Okay, this is pretty straightforward. Okay. The main topic for today. First, we're going to start with protractor postulate. What's a protractor, by the way? You all know what a protractor is? Remember, like your third grade, during your What is that? What do you do with it? Yeah. Yeah, it's a tool that helps you measure an angle, right? You've seen that before. So this postulate is called protractor postulate. This is all you need to write down. I don't want you to write the rest of them unless you want to. And if you want to write it, go ahead and write it at home because we don't have time to write all this, okay? But we're going to explain this. We're going to go over it like last time. So, do you remember ruler postulate? It gave us essentially a ruler, right? It gave us a number line, right? It gave us coordinates and it tells us how to find the distance between any coordinate. Anybody want to guess what it's going to do for this one? It's sort of a deja vu. You could think of it instead of for like ruler lines and segments. We're going to do something with angles. What do you think, sir? What do you think this is going to establish?
It gives you like angle system.
Yeah, it's going to give us angle system. Yeah, you can say it that way. It's going to define for us how to set up what an angle is, okay, and how to measure these angles and so forth, okay. And we all know how to do this already. Why are we doing this? Well, it's for people that had no idea what this was, okay. So we'll be on the same page when we talk about angles and so forth. So let's see if it makes sense. Even though the word that is described is maybe like, what is it? What are they talking about? But it's something really simple. So you don't have to write this down, guys. Okay, so it says on line AB in a given plane, it says choose any point O between AB. Do we know how to do that?
Yep.
Yeah, let's do that. Okay, let me actually do that for you. Let's do this together. Here. So let's draw a line AB. Do we know how to draw a line AB? Is that easy or hard? It's easy, right? Here is line A, line B. Line AB. Are we okay? Well, what do they tell us to do next? Choose point O between AB. You guys remember what it means when they say between AB? It's got to be what? On that line. Okay, so does it have to be right in the middle? No, it doesn't say it has to be in the middle. As long as it's between. So I'm just going to put it right here. Is that okay? Oh, that's all they're telling us to do. Now, it says consider OA. Okay. I mean, it's ray OA. There's ray OA. What's the other ray? Consider OB. There's OB. Okay. Yeah, that's fine. Okay, consider. Okay, I see that. Okay, it's there. Yeah, so what? And all the rays that can be drawn from O on one side of AB. Look at this. AB separates this whole plane into two sides, right? One above or one below, right? So let's just let's just choose the top part. Is that okay? And it says consider OA and OB and all the rays. How many rays can you? Yeah, infinitely many can be drawn from O. Infinitely many, right? It could be this one here. That's one ray. How many? How else could I do this? Here. I could do this all day, right? Here. Here. Huh? Fountain. Okay, fountain. Fine. Okay. But not a fountain. What are they trying to do? Anybody see what they're trying to do? They are trying to show us that there are infinitely many rays. Huh? Yeah, it's like a protractor, isn't it? Look what they say later. Okay, here. That's why it's called protractor postulate. Look. And what they say here next. O, A, B, these rays can be paired with the real number. Does that sound familiar? Between 1 and 0 and 180. Isn't that how we, right? Straight angle is how many degrees? 180. So they're basically saying, right? All these could have numerical values, okay? What do you think this one, like right here, that makes 90 degrees? Oh, I said it. What do you think this numerical value of this ray will be? 90. Does that make sense? You get what I'm trying to say? Okay, guess what? This one's going to have a value of 0. This one will probably have 180. Does that make sense? Maybe this one right here will be 45, right? You know what I mean? We could do this for every single ray that you could draw. You all agree? Can we not do that? Right? So they're basically telling you what an angle is, really. Right? Okay. So remember, this is sort of the same thing that we did with the number line for ruler postulate. You guys all understand what I'm saying? So that now, see here, OA. Oh, I drew it the other way. So let me draw this. OA is 0 degrees. So I did it the other way, but it could be other way. It's fine. OA is 0 degrees, and then OB is 180, and of course this will still be 91 in the middle, you know, right? You all get what I'm trying to say? And this one before. What would this be? It's not going to be 135 here, this one will be 45 or something. You know what I mean? You get the idea? That's what they're saying. Okay, so that's what, let's see whether we understand the second part then. So we got this part right here, right? OA is paired with 0 and OB is paired with 180. Of course, all the ones in the middle is going to have some values, right? 0 through 180. And what's this? Remember the second part of the ruler postulate? What did the second part of the ruler postulate tell us? After we established a number line, it told us how to find the distance between any two points. Guess what? This is going to tell us how to find an angle between any two not points now. We don't have any points. Rays. It's going to tell us how to find the angle between any two rays. Okay, does that make sense? So like last time, you know how the second part of the ruler postulate told us how to find the distance between any 2 points. Now it's going to tell us how to find the angle measure between any two rays. Do you know how to do that? Let me see. Let me ask you this. You do? But okay. So let me show you. Whoops. There you go. No. This one you don't have to write. So let me move up here. So let me ask you this. So you know how if I have a line here. Here's an angle. So the second part, it will show me how to find an angle between any two angles, right? So let's say that I have this angle right here is, I don't know, 45 degrees, okay? And what's this angle going to be? This one. So do you know how to find, what would this be? About 135, fine, okay. Then can you find the angle measure between these two rays? Just like we found the distance between 2 points. Do you know how to find this angle right here? Yeah? What is that going to be? Anybody? Yeah?
You subtract it.
Oh! Does that sound familiar? 135 minus 45. What does that give you? Does that sound familiar? You subtract them, right? When did we do that? Ruler postulate. Didn't we find we actually took the absolute value of their difference of their coordinates. Same thing here, right? Look, can I do 45 minus 135? What do I get? I get negative 90. So if I don't want to care about the order, all I have to do is what? Take the absolute value. Do you guys get this? So we're going to do the same thing. This is what it's going to say. Look, let's see if it makes sense. So if OP is paired with X, this is X. If OQ is paired with Y, they're going to tell you how to find the angle measure between these two rays. Well, how do you find that? Well, you find if this X was, I don't know, 40 degrees, if Y was 100 degrees, what's this angle measure going to be? 60. And isn't that how we find it? We take the absolute value of their difference. So do you see how it's very similar to what we talked about last time? You guys get this? So just like last time, it tells you how to find the angle between two rays. Okay? So let's do an example. What if X was 40 degrees, Y was 70 degrees? What would the angle between those two rays be? So any question? Is this easy? Very good. Okay, now you don't have to write that one down. But this next one, like last time, is going to be the important one. So let's write this one. So let's move on to. What did you say? We're gonna be doing that what? That's right. We're gonna, like segment addition postulate. We're going to now talk about angle addition postulate. Anybody want to guess what this will say? It'll be very similar to what we did last time too. Same people? Someone else? Come on. How about Wonjun, Gongwon? What do you think?
You add angles to make it bigger.
Yeah, you basically add the two angles, right? And it'll be the total angle, right? Now, what sort of angles are we talking about? This angle has to be 180. It doesn't have to be. No, it doesn't have to. Okay, so, all right, here, I will give it to you. It could be any angle. Look, okay, but the ray has to be in between. So look, it says, if point B lies in interior angle of any angle, AOC, you see how B is inside? Okay, and you could draw a ray there. Guess what? The angle on top plus the angle measure on the bottom, it equals to what? The angle measure of the whole thing. Okay, same as before. It could be any angle you want. Doesn't have to be acute, obtuse, whatever. It could be anything. Okay. Any question? Huh? Do you understand? Do you see how they chose that point B inside this angle? Right? It has to be like that, right? Then you can add them together and then it adds up to the whole thing. Now, there's a special case for this angle addition postulate. What do you think this will give you? If angle AOC is a straight angle and B is any point not on line AC, then what's the measure of, by the way, that N means measure of. Do you guys know that? Okay. Measure of angle AOB plus measure of angle BOC equal to. Go ahead and fill in this blank. Let me give you a hint. Go ahead and draw this. It's going to be very obvious if you draw it. Go ahead. I'll give you. Yeah, question?
What's the word next to
Angle and.
No, the word for.
Okay, some of you are still having. Okay, if I were to draw this, like I said, did you guys listen to me when I told you to draw? Okay, go ahead and draw this. Here. Do we know how to draw angle, straight angle?
Yep.
Yeah, A, O, C. Fine. There's straight angle. It says pick a point that is not on this line, right? So here, pick a point B. Is that okay?
Yeah.
Is that a good point? Does it have to be there?
No.
No, as long as it's not on this line, it's fine. Now, of course, I could draw a ray, right? Look, what's measurement of AOB, this one angle, plus this angle?
180.
That's all we're saying, okay? So for this angle addition postulate, if the angle happens to be straight angle, of course, their sum is always going to be equal to 180. That's all they're saying, okay? Nothing hard. Any question? Are we good? Do you understand now? Yechan? Do you get it? Do you get this? All right. Let's then move on to. Now the rest is pretty straightforward. Congruent angles. Anybody know what congruent angles are? We're gonna define it for you. Sort of like you know how we did congruent segments? Same thing. What do you think? Who thinks they know? Yes, sir.
They are angles that have
Same side?
same measure.
Same measure. Exactly right. So angles that have. By the way, that's the symbol for it. Congruent angles. You see congruent symbol and with the angle symbol. Congruent angles are angles that have equal measure. Here's an example of two angles that are congruent. They both have 40 degrees as its measure. And of course you could write it like this. Angle A is congruent to angle B. Or if you're going to talk about their measurement, can I use congruent symbol or should I use equal sign? Equal sign if their measurement is equal. Does that make sense? All right. Adjacent angles, and this is a symbol for it. Anybody know what adjacent angles are? So many times people actually give me the definition that is almost true but not quite. Okay, so you gotta be a little bit careful when you remember we have to be all on the same page, right? If you say it in a different way, people may think of different sort of scenario. What do you think? How about Kevin? What do you think?
Angles that are right next to each other.
Okay, Andrew, do you want to add something to that?
Angles that share a side.
Okay, so Kevin said angles that are next to each other. If you say that,
I said right next to each
right next to each other, sure, here's an angle. Here's an angle, they're right next to each other right there. Are these adjacent angles? Aren't they right next to each other? Are they adjacent angles?
other. They are.
Oh, what? Say it again?
The same
With the same vertex. Good. And you said what? Same size. So you gotta say both of those. Very good. You see how you gotta be careful? Otherwise, okay, good. Yeah, that's what we're talking about. No, this one is not an adjacent angle. They're not adjacent angles. They have to have it here. Here's the definition. In order for the two angles to be called adjacent angles, they have to have common vertex and common size, but no common interior points. Okay? Because if they did have common interior points, they could be the same angles or something, right? But we know when we say two angles, we mean two different angles, right? So anyway, so this is a picture that you should think of, right, when you're talking about adjacent angles, and that's why we have to say they have to have a common vertex and common size. Okay. All right. Any question? Yeah. Okay, bisector of an angle. Like I said, it's sort of similar as last time. We talked about bisector of a segment. What can bisect an angle? Oh, by the way, what do you think it is, bisector of an angle? Okay, somebody I didn't pick. Who didn't I? Oh, I didn't pick. Hannah, what do you think? Two equal or congruent angles is exactly right. Yeah, the book does say ray, right? It's the ray that divides the angle into two congruent adjacent angles. See, it's important that it actually divides into congruent adjacent angles, okay? Not just congruent angles, but adjacent. They have to be right next to each other with a common vertex and share the same side. Notice we're using that adjacent angle, right? The definition there, carefully. It says ray. It turns out it could be a line too, okay? It could be a line. Remember we talked about it could be a line. What else? It could be a line segment. It could be a plane. It doesn't have to be a ray only, okay? Okay, so anyway, that's the bisector of an angle. It divides the angle into two congruent adjacent angles. Okay, guys? Can I leave out the adjacent part? No. Okay, then it will not be a bisector. May I move on? No? Okay, go ahead and write it down. You're correct. So if you say, yeah, I don't think we should include a line segment, right? Because line segment would not divide this forever. It'll stop. Yeah, I said it wrong. You're right. Thank you. Hey, you get to wear this thing. Hold on a second. You get the Spartan star thing. Yeah. It actually, okay, so very good. Thank you for pointing that out. She's correct. The reason why it says ray, not a line segment, but it could be a line. Line is okay, right? Or plane. But you cannot include segment, right? Because segment stops. It has two endpoints, doesn't it? Right? Because the angle goes on forever. Very good. Excellent. May I move on? Okay, good. Last thing I want to do is, okay. Yeah, whoops. Let me get rid of this. I'm trying to erase this thing. How come it's not? Oh, there you go. Okay, what can you conclude or assume from this diagram? Okay. Yeah, what can you assume from this? So if you saw this on a homework page or on your test, what can you assume? Yes? Angle CV is a right angle. How many people say yes, we could assume that CBE is a right angle? The answer is no, you cannot. Why not? You don't have to write this. Yeah, you don't need to. But if you want, it's fine. It's no big deal. But I want you to understand. How come I cannot? Doesn't this look like 90 degrees? Why can we not assume that's 90? Yeah. Right, because I haven't told you that it's 90. Just because it looks like it's 90, can you assume it's 90? No, what if it's like 90.00001 degrees? You don't know. But what if I do this? Now, can you assume that that's 90? Yes, then you could assume. Okay, also, can you assume that this angle, ABD, can you assume that BD is a bisector of angle ABE? No. Does it look like it? Yeah. But can you assume? No. But if I did this, now can you assume that it is a bisector? What does this mean? That these two angles are congruent. Does that make sense? Okay, so on your homework, please be careful, okay? Good.